When you're asked to perform a textual substitution into a quantification, there are a few more considerations than a typical textual substitution. Specifically, you need to consider whether or not the dummy variable in the quantification occurs free in the expression that you're trying to substitute into the quantification. In this case, we kind of have two quantifications. If we break it down, we have this y quantification in here, and then kind of wrapped around it, we have this big one with x. So when we perform this textual substitution, we're going to kind of target the outer quantification first. So we take a look at our dummy variable x. We need to check, okay, does x occur free in the expression that we're trying to substitute in? If it didn't occur free, we could carry on with the textual substitution as usual and simply go about replacing all instances of n with x plus y. However, we have the dummy variable x here, and we have a free occurrence of x in our expression that we want to perform the textual substitution with. Now, this is an issue because x occurs free in here, but everywhere inside this quantification, x is bound to this dummy variable x. If we were to simply take our expression over here and plug it in, we would run into an issue where we might inadvertently bind a free occurrence of x. In order to correct this, it's a simple fix. All we need to do is take the dummy variable in here and replace it with some other variable. What specific variable we use as the dummy doesn't really matter, which is why we can replace it with something like I or J or K. And that way, when we take this expression and we plug it in, we won't run into any issues where we're going to bind a free occurrence of a variable that exists in both expressions. So in this case, let's take our dummy variable x and let's replace it with I. So the formal mathematical way to do this, if we were to rewrite it, we would say, okay, we have our asterisk here, which just represents any quantification. It's a bit of a general expression. We're going to replace x with I. And then in here, if we wanted to write out all of our steps formally, what we could do is, okay, we have this thing here. So we're going to say 0 less than or equal to x less than z. And then we're going to write in a textual substitution where we're taking all occurrences of x in that part of the expression, and we're going to replace them with I. And then we're going to just carry down this right here, and now we have this big y quantification. So we're just going to put all of that still in the brackets. We're going to say, okay, we have the asterisk, we have y, and then we're going to have 1 less than or equal to y. And then we're going to have x plus y plus n. And in here, we're going to take all occurrences of x, and we're going to map them to I. Now, the reason it doesn't matter over here is because there aren't any occurrences of x to change, but in this part of the expression right here, we do have an occurrence of x we want to replace. So we're just going to close that bracket, and we can close the larger bracket and simply carry down the n substitution over here that we haven't performed yet. So this is what our expression would look like at the next step. And now we can simply go ahead and perform these textual substitutions. These expressions here, these are just normal textual substitutions. So all we have to do is take all occurrences of x and replace them with I. So we're going to do that in the next step. So we're just going to carry down everything else exactly the same. We have our quantification over I. Now here we have one occurrence of x. We're going to swap it out with I. So we have 0 less than or equal to I less than z. And then in here, we don't touch the y quantification. We've got 1 less than or equal to y. And now we're going to take our one occurrence of x over here. We're going to swap it with I. So we're going to say I plus y plus n. We can close that bracket and we can leave the n substitution as it is out here. So this is where we're at now. So now we can take a look again. Let's try again to perform the substitution we want. So we have this expression and we have this dummy variable. Does dummy variable I occur free in x plus y? No, because there aren't any occurrences of I in this expression at all. So we are safe to start actually performing the substitution. So what we can do at this stage is simply carry in the n mapped to x plus y into the two terms of our quantification. So the way that that would look is a bit like this. We're going to have our quantification over I, and we're going to have 0 less than or equal to I less than z. We can put brackets around that and then bring in the n mapped to x plus y. We're just going to bring this down here. And now we have the big y quantification. So we're not going to touch anything in there. We're going to have 1 less than or equal to y, I plus y plus n. And then we're going to bring in the n mapped to x plus y. And then we can close that big bracket there. So all we really did here was we took this and we kind of distributed it into the smaller quantification here and into the I quantification over there. And I think I realized here I forgot to close that bracket. So now our expression looks like this. So now we need to carry on with performing these substitutions. So in here, we can go ahead with this one. This is just a normal textual substitution. And if we take a closer look, we'll realize, well, this expression doesn't have any instances of n to replace at all. So this basically just disappears. There's no n's to swap out, so this expression stays exactly as it is. This one, however, is another textual substitution into a quantification. So we have to take into consideration our rules again. So we take a look at the dummy variable present in this quantification. This is y. Does y occur free in x plus y? Yes, it does. Much like x did, y also occurs free in this expression. So we need to perform the same process again. We need to swap out the dummy variable in this quantification. So let's swap out y with j. So in order to do that formally, we can write our next step here. So we're not going to touch this sort of left part of this quantification. We've got the quantification over I. This expression is going to stay the same because there was no n to replace. So we've got 0 less than or equal to I less than z. And now we're going to replace dummy variable y with dummy variable j. And the way we would write that out formally, just like last time, we've got 1 less than or equal to y. And we're going to say y is being replaced with j. And we're going to have I plus y plus n. And we're going to say y is being replaced with j. And if we close off that bracket there and the next one, or actually we just close this bracket here and then we do n mapped to x plus y. And then we close that bigger bracket because we've already dealt with the n mapped to x plus y in this part. So now we're really only taking a look at this y quantification here. So we can go ahead and perform our dummy variable swap. All we need to do is perform this textual substitution and this textual substitution. So all that's really going to mean is we're going to take all of our occurrences of y, we're going to replace them with j, just like that. And in here as well, you're going to take that y, you're going to replace it with j, just like that. And now with this performed, we're free to go ahead and take this n substitution and actually carry it out on this y quantification, because now there's no longer any free occurrences of y that are being bound in the quantification that now uses j as its variable. So if we were to go ahead and perform that substitution, all we're going to do is we're going to take our one occurrence of n, and we're going to replace it with x plus y. But if we were to write it out formally, we would put n mapped to x plus y here, and n mapped to x plus y here. And then we could get rid of it out here. So we've just kind of brought it into the quantification, kind of like what we did before. And again, looking at this expression here, there's no occurrence of n to replace, much like this one was over here. So we don't do anything to this expression because there's nothing to perform the substitution on. So that stays exactly as it is. But in this one, we have our one occurrence of n. So all we're going to do is we're going to take that occurrence of n and we're going to replace it with x plus y. So if we do that, it's going to look like this. And now if we write out our final quantification with all of our changes made, we're going to have the quantification over I, 0 less than or equal to I, less than z. And then we're going to have the quantification over j, 1 less than or equal to j, I plus j plus x plus y. You're going to close that bracket and close the big one. So this would be your final expression. So as you can see, basically the process is something along the lines of take a look at your dummy variables. Do they occur free in the expression you're trying to substitute in? If so, you just need to swap out the dummy variable and then you can go ahead and carry on with your substitution as per normal. The goal is basically to take something where you might inadvertently bind a free occurrence and get it to a place where that's no longer a risk, and then simply distribute and perform the textual substitution as you normally would.